So when it comes to combination of cells, we can combine the cells in three manners. One of the manners to combine them is in series. One of the manners to combine them is in parallel. And then there is a third manner to combine them, which we say is the mixed grouping. This is the mixed grouping. So before we come to mixed grouping, let us look about the series and the parallel combinations. So suppose we have these cells. I have drawn only 3 cells here for representative purposes, but you can assume that there are n such cells. There are n such cells. Each of these cells has a EMF E and an internal resistance R. EMF E, internal resistance R. And that is true for all the n cells. And there is a current I which is flowing in the circuit through an external resistance R. So what is the total EMF in this configuration? The total EMF of this combination, that is equal to the number of cells n into the EMF of each cell, that is n into E. And what is the total resistance? The total resistance in this configuration, that is equal to the number of cells each having internal resistance R, so n into R plus the external resistance R. Therefore the current which is flowing in the circuit in this configuration is given as NE divided by NR plus R. So this is the expression for current. Here the cells are in series combination. Let us now look what happens when they are in parallel combination. Again we have each cell of EMF E and internal resistance R, but now instead of being connected in series, that is n such cells in one row, we have n such rows, and in each row there is one cell. Each row contains one cell. So there are n such rows and each row contains one cell. So what is the net EMF and net resistance in this configuration? That is to say the total EMF. The total EMF, that is still equal to just E. That is when they are in parallel combination, each cell having an EMF E, the total EMF is also E in this case, because the positive poles of all the cells are connected to one point and the negative poles of all the cells are connected to another point. The EMF remains E. And what is the total resistance? The total resistance in this configuration, that will be equal to 1 by R dash, which is 1 by R plus 1 by R, that is each of these individual cell up to n terms. So one can see that R dash comes out to be R by n, and therefore the total resistance is R dash plus the external resistance in the circuit, so R by n plus R. Therefore in this case the current which is flowing in the circuit, that current is equal to E divided by R by n plus capital R. So that turns out to be n into E by n into capital R plus small r. So the other things remaining the same, the n instead of being in front of small r just changes and comes in front of capital R. So these are the series and parallel combinations. In mixed grouping, we have both series and parallel combination coming into act together. So what happens in mixed grouping is that in each row, this is one row, in each row there are n number of cells, and like this there are m number of rows. So in each row we have n number of cells, and in total there are m such rows. So for each row, the EMF, that is the net EMF, E net, that is equal to the number of cells into EMF of each cell. EMF of each cell is E. And for each row, the net resistance is N into R, where R is the internal resistance of each cell. And now when we look into picture, that is the entire picture of all the M rows. For all M rows, the EMF that still remains NE because they are in parallel combination, and the resistance 1 by RT, that will be 1 by NR, and so on, added up to M terms. So here you see that the resistance due to the cells, or in other words the resistance of this entire battery, that turns out to be N into R by M. So this is the resistance of the entire battery. So total resistance R total will be NR by M by the external resistance in the circuit R. So in this configuration, the current that will flow in the circuit due to the battery will be NE divided by NR by M plus capital R. So on simplification, it becomes M into N into E by N into R plus M into capital R. So what happens in mixed grouping? Once again, in each row we have n number of cells. Each cell has an EMF E, but they are in series, so it becomes N into E, and they are each cell having internal resistance R in series, that becomes N into R. So that is the configuration for each row, and we have M rows. So these NR, they are in parallel for the M rows, and the EMF that will still remain NE, as we saw in case of parallel combination up here, that the EMF remains the same. And then whatever resistance we get, this is the resistance of the battery that is formed due to the combination of all these cells in series and parallel. And then we have the external resistance R, and total, adding them up, we get the expression for the current. So this is the current which is flowing in the circuit. And you will see there will be a condition given in the book that current I is maximum when the external resistance in the circuit is equal to N into R by M. That is to say, when this is equal to this, that is when the current becomes maximum. So this is mixed grouping, where we will have cells in series, and there will be many such series which will be connected in parallel. So we will have them all connected in series, and many such series will be connected in parallel. That is mixed grouping.